Alright, welcome to the NUPOC video study guide number 21. Let's look at question 18 in the general math section of guide 1. So this question just asks us for the dimensions of a box with a certain height, width, and length given some basic relationships. So what they give us is that the length is twice the height and that the width is 10 meters less than the length. And also the total surface area, we'll write as cap S, is 10 times the width times the height. So those of you who are following along with the guide will notice that the word problem in the guide is a little bit more verbose, but this is essentially what it's setting up for us. And if you're looking at the solutions, you'll notice that they go ahead and they solve for L first. We're going to go through and just solve for H first. So let's get started. So the first thing we'll just do is write down what our surface area would be if we were actually writing it out without this relationship here. So it would be 2 times HW, right, for these two faces, front and back, and then 2 times WL for the top and bottom, and 2 times HL for the front and back. So that is going to become, once we substitute in our, we're going to substitute in this 2H for the L's, and we're going to substitute this equation in here first, and that's going to give us, right over here, that's going to give us W equals 2H minus 10. And then we're going to sub this in for our W's in this equation. So we're going to have everything in terms of H. So we'll have S equals 2 times, and we'll have the first term, that's H times 2H minus 10, plus W, which is 2H minus 10, times L, which is just 2H, plus H times L, which is just 2H. Right? So that means S is going to equal 2 times, this is going to be, the first term would be 2H squared minus 10H plus 4H squared minus 20H plus 2H squared. So if we just collect some terms here, this will be, let's see, we've got a 2H squared and a 4H squared and a 2H squared, so that'll be 8H squared minus 10H minus 20H, so that'll be minus 30H times 2, so that will simply be 16H squared minus 60H. So this is what our S equals, and we also know that S equals 10 times WH, and we know that W equals 2H minus 10, so we're actually going to, I know I've got a lot of lines over here, but just try and just follow each one of them. So W is going to get substituted in here, so we can actually say that S also equals, coming down here, 10 times 2H minus 10 times H, which is going to equal, let's see, that'd be 20H squared minus 100H. Okay, so now we can just equate these two equalities because they're both equal to X. They're both equal to S. So we can equate the other two sides here. So we can simply say over here we can bring these two together. Right? I'm just going to go on to another page here quickly. So we're going to have a 20H squared minus 100H equals 16H squared minus 60H. Let's go ahead and add 100H to each side, so we'll get 20H squared equals 16H h squared plus 40h. Let's subtract 16h from both sides, and we will get 4h squared equals 40h. Now let's kind of just bring all this to one side of the equation. 4h squared minus 40h equals 0. Let's get rid of these. Let's divide everything by 4, and we will get h squared minus 10h equals 0. Factoring out one of those h's, we will get h times h minus 10 equals 0. So either one of these terms could be 0. So looks like one possible solution is h equals 0, but that's sort of the trivial case and not really of interest to us. So let's look at this other term here. So it looks like h equals 10, and I'll just put the m there for meters, is a solution for h. So now let's plug this back in to our previous relationships. We knew that L equals 2h, right? So that means we have L equals 20 meters. And we also know that W equals L minus 10 meters. So that would equal 10 meters. So just rewriting all of this to make it easily interpretable, we have h equals 10 meters, W equals 10 meters, and L equals 20 meters. And you can check that with the solution in the solution manual if you're following along, and you'll find it does agree. And that's just a slightly alternative way of doing it. We just solved for a different variable first. But in either case, that's just a quick way to go from having a